Hey, good morning, everyone. Welcome to 2H session from Andrew from IBM. So this is integrating with the mainframe and what are your options? So I'd like to hand it over to Andrew. Go ahead.
Oh, good morning. Thank you very much. So, as Rick said, my name is Andrew Smithson. I'm a software engineer at IBM, and for about the last 20 years, which was a scary number to realize, I've been working on products that have enabled um, applications that may not be running on the mainframe to talk to programs that are based in systems that are running on ZOS. Um, so, yeah, as Ricky said, please feel to post your questions, comments in the chat. I'll hopefully try and leave a bit of time at the end for any questions, but please feel free to drop a comment in there, and we'll get going with the discussions and the talk today. So, when it comes to working with applications on the mainframe, I think a lot of the people still think that we're stuck with 3270 terminal-based applications, a green screen, where you've got to type everything with a keyboard. You've got to try and find where the F keys are on your keyboard. And this is the kind of interface that we're looking at. And for a long time, this was true, but it's not anymore. And what I'd like to do in this talk is kind of show some of the options that you would have available, and things you can think about if you're asked to kind of make something that talks to one of these programs or provides a new interface into those kind of things. So the first thing to kind of just talk about is a lot of the structure that we end up with applications on the mainframe. And there was a strong push, certainly from IBM, in terms of when building out mainframe applications to follow the model view controller way of doing things. So you have the model, which is what data is available. So that could be your customer record, that could be the order that's being processed through, that could be your bank account with the various balances and the list of transactions that have gone through that, where money's gone in and out of the system. You've then got the view, which is how it looks to the user. How does this person interact with the application? So as we showed on the previous slide, this would have traditionally been a 3270 based interface. You'll hear terms like BMS maps and basic mapping support and things like that going through. And then you have the controller, which is then what takes the information from the user, maps it onto the model, makes the updates that are needed, or gets the information out of that model. So what we're looking at with these kind of applications is if they've been well defined with those links in between, what we're able to do with some of the tools and techniques that we'll talk about is that we can drop out that view box on the left, and then have something else that talks to the controller using the interfaces and the things that are available with the mainframe software. So there's two main kind of products, mainframe-based application servers that I'm going to talk about today. First of all is CICS, which is the Customer Information Control System, mostly developed out here in Hursley today. And it's where I've spent the majority of my career within IBM. And so we're talking between the different programs that are running inside a CICS transaction server and the programs there. There are two ways of transmitting data in a structured way between the programs. The first is the COM area, which is a communications area. And I've described it there as a big data area. It's got a maximum size of 32 kilobytes, which isn't excessively big in this day and age of 64-bit computing. But, way back when this first got developed, that was, you thought, that would be big enough for everybody. But it ends up just being, a big block of memory. So all the fields and things that you'll be that are worked with inside the programs, they're defined in what's often known as a copybook. So you'll have a list of all those fields, and effectively they all just get munged together into one big block of data where they're all serially laid out. And you've got to define the maximum sizes for each of those things. And if they start overlapping and overwriting, you've got all kinds of programming headaches that you're going to have to think about. But we can see there, where we have two simple fields of a string, which is our request ID, and then a number stored as characters, which is our return code. We could use the hello and 32, and then those would form the EBCDIC bytes that we show underneath it, with the key thing being that there has to be that extra null character for the space between the end of the string and the start of the number to make sure we've got the right number of characters and bytes in that structure every time. So these are still used today. There's lots of programs that will be making use of this and things like that going forward. But as I say, 32 kilobytes, not a huge amount of storage. And there are parts of structures and programs and things like that that need to work with larger data areas. And so there was, lots of customer requirements, to make this bigger. And the Kix development team could have just doubled it or, quadrupled it, and that probably would have been enough. But what they actually did was they came up with a whole new structured way of passing the data around called a channel. And inside a channel, you have what's called containers. And these are not the same as Docker containers or anything else like that. It's just a space to store some data. But each container in that channel has a name. So you can reference each of those things by name and just get the one you want by name. And it can be encoded so that it contains string data. And that also takes care of some of the data conversion issues that you can face when communicating on and off platform. Or it can contain binary data. So it could contain a single field. So it could just contain our return code field there. Or it could contain a structure, so you could treat it like a COM area. And then the maximum size of each container in your channel is 2 gigabytes. So depending on how much memory and working storage your application gets hold of, effectively, you're only limited now by what's available on the machine rather than some limitation inside the application server. And then if you're using IMS, it's a similar idea. So IMS, you have a queue of messages that will be read off by the application in terms of that controller. And a message can be made up of a number of segments. But to my mind, and this is, as I say, I'm more of a Kix focused history rather than IMS, but it's like a COM area in that sense. It's structured data. You've got to make sure that all your fields line up and how you're working with that going forward. So one of the challenges that we can probably see that if we're working with these kind of COM area or message-based data structures is that actually trying to do all that serialization and dealing with data types that only really exist in things like COBOL. Pax decimal is probably one that you'll hear if you start working in kind of those environments. It's not as straightforward to work with in languages such as Java, which have a higher level of abstraction from the kind of the memory that you're working with. So to help with that, there are ways of working and tools that will generate you Java classes and other structures based on the actual COBOL code or the assembler code that you're working with. And one of these is the IBM record generator, which is available, I think free. So you can go off and find it. And when I upload these slides, I'll go through and add all the links and stuff to the relevant pages. But what this will do is it will take the output and the data that the compiler can provide around your COBOL structures that are used within your programs and use it to generate you a Java class or an XML schema that will then work with that. So then when, rather than having to pick out lengths and parts of what effectively would be a byte array inside your Java class, you've actually got an object with methods that you can use to get and set. And that will take care of ensuring that when you serialize and deserialize that kind of COM area record, you've got things at the right lengths and things like that. You're not overwriting data or corrupting other fields as you're going down the line. So with that kind of information that we have in place, the first thing we're going to look at in terms of ways that you could integrate with those programs is that there are products out there that will give you a set of programming or language APIs for working directly with a Kix program or an IMS transaction or something like that. And these could work in a number of languages, predominantly the ones we've got on the left, so Java and .NET and C and C++. And the idea here is that you have enough space inside that programming API to set up not only the program that you want to call and the parameters that you want to call it with, so setting up that COM area or setting up a channel and things like that, but also things around security and who you are and calling that. And then the rest of that language API takes care of how we get that information into the Kix or the IMS system. The program will then run, and then you can get the results back, whether it's successful, whether it abnormally ended with an append code, and things like that. So there's lots of things like that, and some really great samples and things like that which you're working on. So if you're working in those kind of languages, you've got options for working with those there. So the main two software options that I can talk about. So a lot of the examples I'm going to give are going to be IBM-based software because that's where I work. These are not the only options. So there are almost certainly going to be vendor products and other products out there that we from other vendors that will do a similar sort of thing, but they will all kind of use the same sort of concepts that we're talking about today. So for Kix programs, you have the Kix Transaction Gateway. So this, I should probably, for full disclosure, this is what I first started working on when I started working at IBM. And that provides those APIs that we talked about. You can do various things in terms of calling programs and getting the responses back. And then you have IMS Connect, which comes as part of the IMS suite of programs that you get with IMS. And that does a similar thing of being able to call into the IMS message processing regions and things like that in order to make sure that you've got a message, putting a message on the queue and ensuring that the transaction gets triggered based off that. So on top as well of just kind of writing programs that you might just run on your as a command type process or in a batch type environment. There's also other applications. You can have Java based application servers, and the main specification around this is Jakarta Enterprise Edition. It was Java Enterprise Edition before Oracle gave it to the open source community, who renamed it. But the idea around this is it's a whole bunch of specifications for working with data and working with other systems and exposing applications in a way that you want to use them. And there's a couple of key things that we can look at if we're using something like WebSphere Liberty as your application server. So the first of those is the Java connector architecture. And what this does is it tries to provide a standard way of working with the APIs, regardless of the backend that you're talking to. So when we were looking at those previous APIs that we talked about, which is the language-specific ones, doing something for a Kix program using Kix Transaction Gateway could look very different to something else that's working with another system such as IMS or some other kind of third-party mainframe system, because they're very bespoke to things like that. And as a developer, if you need to work across lots of systems, that's very hard kind of keeping all those different paradigms and different API specs and things like that in your head. So the idea behind JCA was that, okay, we can abstract a lot of the things that we want to do with those backend systems. So we want to call programs, we want to pass input, we want to get output, and then work with it. And gives a common set of interfaces for the consumer to use, and then a way for all the software vendors, such as Kix and IMS, to provide a set of tooling that plugs into that, but then also does all the secret sauce of how it goes off to the main systems. So you'll find JCA for both Kix and IMS as part of Kix TG and IMS Connect, and they can work inside any Jakarta Enterprise or Java EE application server to make those calls and bring those back in. The main reason I kind of talk about Liberty on this slide is that there's another option when you're using something like Kix as your application server, is that you can run a Liberty instance or multiple Liberty instances, as it were, inside your Kix region. And this kind of allows you to really bring both of those worlds together, so you can use all the tools and techniques that you have for writing enterprise or JEE applications, but also then easily link in with the tools and the programs and stuff that are running inside your Kix region. And to do this, there is a set of APIs called the JKix APIs. There's a couple of versions of this. And what they do is they allow you to effectively do what a COBOL developer would have done inside their Kix programs in terms of working with resources, calling other programs and things like that. But you do it in a way that makes sense and is intuitive for a Java developer. And you can just write it and include it in a bunch of your Java applications that are running inside Liberty. So kind of the final thing on kind of this sort of slide is, why would we do, or why would you choose to use one of these techniques or one of these language APIs or using Jakarta EE or something like that? So one, it might be that you're actually forced to. There's always those times we get with building software and writing new applications that we just get told, do it this way because that's what you've got to do. But if you have a lot of free choice, and occasionally we do get that freedom at times, you need to kind of think about the whys and what the capabilities are that we get with that. So as we say, you can integrate those things, if you're using those APIs, so JKix or the JCA type stuff, or JDBC for talking to databases, that easily integrates into those application servers. If you're using the .NET framework and the application servers you get there, again, you've got .NET-based APIs that easily integrate and work with inside those frameworks. So that can be a good reason. The other is in terms of what you need to do inside those applications. And transactions are the real key driver for a lot of these use cases. So when we come on to later in this presentation, we'll talk about REST APIs and things like that. They are very much a kind of a one and done type of transaction. So we'll go off to the backend system, we'll ask it to do something, and that succeeds or fails, and then we know whether we've had success or failure. But there are other application type situations where we want to work with multiple resources, or we want to do multiple things inside a single transaction. And at that point, those kind of REST APIs and asynchronous type things aren't always the best way to do this. And you actually need to take a bit of control, or you need your application server to actually coordinate that transaction for you. And that's where you would use these kind of things. So there's a couple of terms that get used around this, especially around kind of Kix type things. So you'll hear about extended logical units of work, which is just a transaction that does multiple program calls. So you can either call the same program multiple times, you can pull different programs to do different things, but the thing that the Kix transaction server as a whole will do is at the point you say everything is done, we can commit, everything gets written, or none of it does, and everything gets rolled back. So you can do that. And then we have the more advanced version where you have a two-phase commit type of transaction. And that's generally what happens if you want to coordinate a transaction across multiple transaction servers. So that could be a Kix region, and it could be another WebSphere application somewhere, say. In terms of the programming, you don't have to do anything different. You kind of set up and say, I want all this stuff to happen in a transaction. And the application servers that you're running in will kind of coordinate everything that needs to be done. We'll make sure all the right kind of flows happen at the right time. Everything is going to go well, or everything is going to be rolled back. So if you're thinking that your application that you're writing, or the way that you need to work with the systems, is that you have a lot of these kind of things happening all at once and all happening or not, then this is the kind of thing that you need to kind of get into and start thinking about. So assuming that we don't necessarily want to write a whole bunch of code and manage that, or we actually have a situation where we have a well-defined resource that we can do kind of just basic CRUD type operations on. So create, replace, sorry, not replace, create, retrieve, update, delete. I do this for a living. I should know this stuff. But REST APIs are the key way that this is done. And pretty much every kind of way I see with a lot of the integrations happening today between systems, when you're going to get access to something new, whether it's the new AI framework that's come out, or where your banking applications are, they all have these REST APIs for accessing the data and making updates and things like that. And I can go into a whole bunch of talks about why REST APIs are great, but that's not the point of this talk. So please feel free to look out for there's other talks that will be done at GS Virtual and when we previous conferences that we've done. But the key thing that we can look at in doing this in terms of you're accessing it to the mainframe is that you can make it look and feel like every other REST API out there. It doesn't, anybody that might be picking this up doesn't need to know that actually they're making an update in a vSAM file eventually on the back end. All they know is they made an HTTP request with this JSON payload, and it gave them the results that they were expecting. And that kind of ease of familiarity really helps in that kind of space of, the mainframe doesn't have to be different. It is just another space where we run applications and we have stored data and we do processing that we need to do it. So there's a couple of ways that you can kind of build these things out. I'm going to start at the bottom of this, and kind of that we talk about Kix Liberty, or you can have Liberty applications. So there's a whole bunch of stuff in the JE specs around building out RESTful services and frameworks for scaffolding those up. And then you could make use of kind of the JCA type interface to then go off and call those programs. So again, you'll be responsible for kind of marshalling the data back and forth and kind of doing that translation between a JSON object and the path parameters and the query parameters and all that kind of stuff, and going into things like that. Or there are products out there such as ZOS Connect. I am the lead developer and architect for this product, but so that's just a bit of full disclosure. But what this does is it makes it easier as a developer to say, right, I want to call this program, and this is the interface it will give me, and then I can map that onto the Open API based specification that I want that to be, and you can work with that, and you can kind of do the mapping you're doing without. And ZOS Connect takes care of a lot of the kind of underlying, oh god, this has got to be a COM area of 16 bytes and stuff like that. So there are ways and tools and techniques of doing this. And the real power of this thing is that once you've got these APIs, they just slot into everywhere else that APIs are being used. They go into the same API gateways, the same API catalogs. The security can be done using tokens and things like that, rather than having to pass out rack FID and passwords everywhere to kind of work on this kind of thing. So we've talked a lot, or certainly I've talked a lot around kind of working on these environments when you had that really nice, clean model view controller way of things that you could break out the view, call your controller programs, and do what you need to do to update the data in the back end. As is always the case in a lot of software engineering and stuff like that, not everybody followed that advice. It's very easy as programs develop and change and grow over time that those clear definitions and demarcation of responsibility get blurred. And suddenly you've got business logic interlinked with your presentation logic, or you've just got one massive program that does everything. And everyone's really afraid to change it because that's your core business, and trying to change that could be really expensive. And the worst thing that can happen is suddenly your bank or your insurance company is in the news because nobody can access their data. So there's other techniques we've got. So screen scraping is, I don't want to say it's a basic technique because there's actually some very clever and useful things you can do in it. But effectively, what that does is whatever software you use for working with it can act on like a virtual 3270 terminal, and it can drive the screens and put things in the right place as if a person was doing it on the screen. So a particular flow that might require you to go through 5 or 6 different screens to get to the right place to update the data, or go into one screen, add in one field that then takes you into the next one. That can all be all automated and done programmatically, such that you just pass in all the inputs up front, and that again could be done via some kind of web UI or a REST API or something like that, and then drive the interface and then pull out the various responses that you get on that screen and return them to the user. So you can interact with the various fields and the data that's supplied, and do that in a very programmatic way. And there's a lot of these tools now that will kind of take those screens and just give you a very basic or rough version of it inside a web browser, shall we say. So you can kind of go from I'm accessing this thing via 3070 to I'm accessing it via a web browser, but I'm still doing the same sort of thing. So I'm still filling in fields, but they're now text boxes rather than just random things with underlines. And it's more visually affordant to see where stuff is going and things like that. And then as you kind of do more stuff in this space, then actually you can start breaking things out and exposing them by different kind of interfaces and building out a whole new kind of interface and kind of web UI or mobile application that then calls in and does these sort of things. And that is great, but it can be a little bit fragile as well. If somebody, for whatever reason, changes one of those screens, which is perfectly possible to do, then you've then got to go back and make sure that all those flows still work. And that can be harder to spot and understand than necessarily someone changing the interface that we're using in a programmatic way, such as the COM area or the channel or the messages that you had going on there. So an alternative, and this is, to show that really that developing on the mainframe isn't closed off. And even though we can be doing a lot of this modernization in terms of providing new interfaces and interacting with those existing programs, it doesn't mean you have to leave them alone and they're sacrosanct and can never be changed. There's some really good tools and ways of refactoring those big monolithic applications and actually breaking out some of those controller type parts into a new program that you could then expose out and use those other things in there. So rewriting the code is a bit of a scary thought, but there are a lot of tools and products out there that will help you do that. And with all the kind of the AI stuff that's been going on, you hear about LLMs and all this kind of stuff, and there's a lot of Watson X type stuff that will really help on this that IBM is able to provide. And I should also point out this is stuff that we actually use internally as well. These are tools and techniques that we can use to help us write stuff on Z. So it should hopefully instill some confidence that this stuff is worth looking at. But you can look at these big programs. You can ask it, what does this program do? What is it trying to achieve? And then you can start breaking out some key points of that and build some tests around it and make sure that, when you used to update a customer record, it ended up like this and it still ends up like this. And if you really want to, you can then look at actually, does it still need to be in COBOL? Could it be in a different language? And that might make it easier to maintain and integrate with other things going forward. So it's just because, your application today doesn't fit into one of the nice models for the integration tools and techniques that we're talking about, or you may have available to you, doesn't mean it can't be made to look like that and stuff like that going forward. So that's kind of the last slide I had, and hopefully that's kind of just shown that there are a lot of options there, and there's a lot of things that can, there may be a lot of things to consider when you're doing it, but also that when it comes to doing this stuff, it's not a case you're just stuck with all these green screen applications. If you're used to writing a bunch of applications, whatever you need to do in Go or Python or things like that, being able to expose APIs out of your mainframe applications, or having those language APIs to call them directly, really provide a lot of options and scope for building things out. So I'd really kind of just invite you to kind of look at what's available there, and look and say, well, just because we don't have a Go way of running programs in Scikit doesn't mean you can't do it with Golang outside and then call into that stuff that's running there, to give a really example that's close to my heart. So we've finished with about 10 minutes to spare. I haven't seen any questions come up in the chat. If there are any more questions or comments or things you'd like me to go back on or anything like that, please ask them now. If not, session feedback is really valuable in these kind of conferences. So we encourage you to go in there just to say what you liked about this presentation or not. It really helps me as a presenter know how to change these things for the future, and for the organisers to see what else might be interesting for future conferences.
Thank you very much. Great. I actually learned something, and I do Kix TS when I first started. So yeah. So if there's any questions, pop them in the chat for me, and then we can get going. If your feedback, you can either use the link on screen or in your BYOA, your own agenda. There is actually a link on each session that you can just click and fill out the form there. It only takes 30 seconds or so. But those will be really valuable for us. Anybody got any questions? Okay.
If anything comes up afterwards, my contact details will be in the GSE stuff. Oh, sorry, the GSUK stuff. There you go, Ricky, I still get it wrong. So please feel free to reach out afterwards if something comes up. I'm more than happy to take questions or have a chat at any point.
Okay, thank you very much. Thank you for doing the session, and thank you to the attendees for coming in. The recordings will be available at some point soon. So thank you very much, and have a good day for the rest of the session. Cheers.
Thanks very much, everyone. Cheers. Bye.
Bye.